final project, I grouped with Wayne Wong to analyze the free music data. We get our inspiration for this project from our previous experience of listening to music. Music evokes different feelings in different people, and after you hear a song, you can tell from its vibe and its sound that it belongs to a certain genre. Using different features, the songs can appeal to different listeners. So therefore, we reach our hypothesis that for this project, that do rock and electronic have same level of energy and decibelity. We decide to probe into these two genres and these two features specifically. And for our prediction problem, we choose to predict the song as rock or electronic, given the decibelity and energy of a new song.
Due to the fact that we found rock and electronic turns out to be the most abundant in amount of the track genre, so we decided to combine all three tables based on the two genres and select the respective features of densibility and energy for further analysis.
During the exploratory data stage, we drew a bar graph of all genres for their decibelity average and energy average. Another reason that we chose electronic and rock is because they are the top two on energy average. We also drew a scatter plot for decibelity and energy for electronic and rock. From the scatter plot, we can see that both genres have decibelity and energy across the axis, and it's difficult to tell in the middle part since the two genres have data mingled together.
The hypothesis testing involves two parts mainly. The first part is to analyze if the decibelity average of rock music and electronic music are the same. Hence, the null hypothesis will be that the observed difference in their decibelity average is due to chance, and the alternative hypothesis will be that it's not due to chance and it's in association with something else. And we do this by using the method of A/B testing and shuffle the labels in the table. In the previous table we see. And after shuffling the table, we found out that the p-value turns out to be quite not in the range of 5% cutoff we chose. So it's safe to conclude that the difference in their average of decibelity is not due to chance at all. The second part of the hypothesis testing is focusing on the energy average. And hence, the null hypothesis is now that the average energy of rock and electronic are the same, and the observed difference in their average is due to chance only. And the alternative hypothesis is now that they're not due to chance. So after using the same method, shuffling the labels and doing A/B testing, we found out that the p-value turns out to be quite less than the 5% cutoff as well. So it's safe to conclude that for the energy average, both the electronic and rock music have the different energy average.
From the hypothesis testing, we now know that rock and electronic actually have different features for energy and decibelity. So for prediction problem, we want to predict if the song is electronic or rock based on the given decibelity and energy feature. We first convert all the data into standard units, then we divide the dataset into test and train set, and we compute each line of the test set to distance to train set and pick out the nearest three neighbors for each test set. We then test the accuracy of this classifier and it turns out to be 80% accurate.
So as for the conclusion, we can see that rock and electronic music have different features of densibility and energy. And when we use classifiers to predict the types of musics, we have a success rate that's close to 80%, which is pretty good. And during the exploratory stage, we found some limitations that first, we do not have enough data for the other types of musics, namely instrumental and classics. And secondly, we can have more electronics in the data so that we can make the classifier more effective because there's predominantly rock music in the process.